Hi, I'm Raz, and in this video we'll be looking at integration by parts twice. So we saw in the last video and what the formula was. I've just put that in the top corner. I'll get straight into it. A few technical issues there. And get a nice colour. So here, if you remember the priority order, we had ln xe. So in this question, it will be x squared that will be our u, and e to the x will be our v dash. So when we integrate e to the x, we'll get e to the x. And if we differentiate x squared, we get 2x. So if we use the formula, we will have uv, which will be x squared e to the x, minus the integral of vu dashed. So that will be minus 2x e to the x. So I'm going to put the constant outside. And we can see here that we have, again, something that needs by parts. Hence, this video is called by parts twice. So we just repeat the process. U will be x, u dash will be 1. Again, v dash will be e to the x, and v will be e to the x as well. So the integral of that will be uv minus the integral of vu dashed, which is 1 times e to the x. And so we end up with x e to the x minus e to the x. And there are some giant square brackets there because we need to be very careful when we substitute it back in because of this minus sign. So when I substitute back in, we have the integral of x squared e to the x is x squared e to the x minus 2 of everything in the yellow brackets. So x e to the x minus e to the x. We might as well expand it and simplify. So we have minus 2x e to the x plus 2e to the x, because the two minuses will make a plus sign there. I'm going to factor out e to the x. So we have x squared minus 2x plus 2. And that is between the limits of 1 and 0. Yeah? So, obviously make a note of that because I'm about to just get rid of some of that page so I've got somewhere to write. So pause it now if you need to. And I'll get rid of the note from my sponsor. And let's continue. So now when I sub in the limits, I will have e to the power of 1 times 1 squared minus 2 times 1 plus 2, which we can see will just end up being e, because e times 1 is e. And from that, we'll have to minus the 0 version, which would have been e to the 0, which is 1, 0 squared, which is 0, minus 2 times 0, which is 0 plus 2. So we would have ended up with minus 1 times 2, which is 2. The final answer will be e minus 2. Hopefully you got that as well. Let's have a look at just the second and final example in this video, which is a fun one. So pause this. Before you do, let me remind you that the priority order, if we use priority order, it is ln xe. So pause the video. This might take you like 5 to 7 minutes, maybe 10 minutes. And I will see you when you're ready. Welcome back. So, follow the list. U must be e to the x. Therefore, u dashed is e to the x. V dashed will be sine x. If we differentiate cos, we get negative sine. Therefore, when we integrate sine, we must get negative cos. Yep, so the integral of e to the x sine x dx equals uv, which is negative e to the x cos x, minus the integral of v u dashed, which will be minus e to the x cos x dx. So, because this is the video of integration by parts twice, if you didn't know what to do there, hopefully you just had a gamble and integrated this bit again. So we have u equals e to the x, u dashed equals e to the x. Oh, and a few pen issues here. V dashed equals cos x, and V will be sine differentiates to cos, so cos must integrate to sine. So it will stay positive. So that will be uv e to the x sine x minus v u dashed. So if we piece that together, what we have is the integral of e to the x sine x dx equals minus e to the x cos x plus, because the minus the minus, what I've written in yellow. So e to the x sine x minus the integral of e to the x sine x dx. So we can see there those square brackets aren't protecting us from anything, so we can essentially just remove them. A bit short on space, so I'm going to get rid of them, serving no purpose. So imagine I just wrote this bit down. So you've had a chance to write everything there, so I'm going to delete that out of the way, so we've got a bit more space. Cool. There you go. Now what do we do? Can you see that this is this? So yeah, you're probably kicking yourself now. We add it over. So what we have is two lots of the integral of e to the x sine x dx equals e to the x sine x minus e to the x cos x. We'll have a c somewhere, plus c. Divide that by 2. Job done. Yeah, so that's the toughest type of integration by parts question I'd expect you to see in an exam. If you do see that, remember the trick we've done here. Otherwise, I've hoped you'd enjoy the video. See you soon.